Hi, good morning, everyone. Hello, welcome back. So today's video is going to be about factoring the sum of two squares. Okay, what do I mean by that? Okay, so what do I mean is if you're given two number, okay, if you have a sum of two number where each number can be written as a square like this, okay, we can factor it out, okay? We can factor the sum of two square. And how do we do this? So the formula say that the sum of two square is equal to the product of two complex conjugates. So what is a complex conjugate? Remember, is a number written in the form of a plus bi, okay, where they share the same real part, the opposite imaginary part. So so I'm going to write two factors, and inside each, I'm going to write complex conjugates. Okay, basically complex number that have the same real part but opposite imaginary part, which is going to be a. I'm going to have a plus bi. Okay, the second factor is going to be a minus bi. Okay, again, to factor the sum of two perfect square, okay, is going to be the product of two complex conjugates that do share the same real part, which is the A, represent the real part, and the opposite imaginary part. Imaginary part is BI, and as you can see, they're opposite. Again, what is that true? Okay, let's multiply, let's undo everything. So let me show you if I use the box method to multiply, okay? So let's multiply. A times A is A squared. A times negative BI is negative ABI. And BI times A is going to be ABI. And BI times B, negative BI. So let's multiply. So a positive times a negative is a negative. B times B is going to be B squared. I times I is going to be, let me change color then, I squared. Okay. So now, as you can tell here, okay, if you want, you could have done also the distributive property. You end up with the same result, okay, the same product. So you end up with here a squared minus abi plus abi, okay? Those two numbers add up, the opposite of each other, so they add up to 0, okay? Minus b squared times I squared, okay? So I'm going to be a squared minus b squared, and I'm going to replace the I squared with -1, and then you end up with a squared, and negative times a negative is a positive. That's where you end up with the plus b squared. So if you don't include the I, okay, you end up with the difference of two square. Okay, so that's why it's very important that when you write the factor the sum of two square, always include the I next to it. So you end up with the sum of two square, not the difference of two square. Okay, so let's move on to our first example. Okay, example number 1. I'm asking you to factor, okay, x squared plus 36. So when I ask you to factor, the first thing I need you to do, okay, you have to ask yourself, can you write each number as a square? I see the first square, the first perfect square, which is x squared, because perfect square is any number that can be written as a square, okay? I see the sum, so I have to ask myself, can I write, is 36 a perfect square? Yes, because I can write 36 as a square, which is 6 squared. Okay, so I identify what is A, okay, and what is B. My A here is going to be X, and my B here is going to be 6. So when I'm going to write it in factor form, factor it, okay, X squared plus 36, you're going to simplify to X plus complex conjugate 6I, don't forget to include the I, okay, and then here is going to be x minus 6I. And that's your final result, the factor. And again, if you multiply, you end up with x squared plus 36. So make sure you include the I inside the factor. So let's move on to example number 2. Okay. So please pause the video and use your example from above to help you factor, okay, this sum of two squared. Okay, so identify what is A. The A is a number without the square. Make sure you don't use the square, because remember, when you multiply, If you write square here, x squared and x squared, you end up with x squared times x squared is not x to the fourth power. And remember, I didn't give you x to the fourth power. The problem started with x squared. So don't use, again, x squared here and x squared again is another x squared into the second factor. Use just the number, drop the square. Because when you multiply, you should be able to end on now x times x is going to be x squared and so forth. Okay. So again, A here is x and B is 11. So let's do number 3. Again, you're going to use a formula for factoring the sum of 2 squared. Okay, right here for you. So number 3 is, okay. So let me model this example, the third one. So this is different from number 1 and 2 because I can see here that there is a common factor, okay, in 2x squared and 128, okay. There's a common number, common factor repeated in both terms, and that number is, you're right, it's the number 2, okay? So you're going to then write 2 times, what am I going to write then here? So I'm going to take 2x squared and divide it by 2, so end up with x squared, and 128 divided by 2, I end up with positive 64. Am I right? Yes, 2 times x squared is 2x squared, 2 times 64 is 128. Now, I can now see the sum of 2 squared. So my tips to you, always factor out the greatest common factor before you want to use you don't want to do any factoring, okay, method that I've shown you. Always pull out, take the number of the common factor needs to come out. So now let's identify what is A and what is B. So can you write each term as a squared? And that base, that number here represent A and B. So you end up with x here and 8. So I will end up with 2x squared plus 128 can be factored as 2 times x plus 8i times x minus 8i. And that's your final factor form. We factor the sum of 2 squared, which is going to be the product of 2 complex conjugates. Now, remember always to plug in to factor out the greatest common factor before you want to apply, before you want to factor the sum of 2 squared. Okay, so let's do this one. Now, I would like you to use, I would like you to compose a video and complete number 4, which is 4x squared plus 100, by using the same thinking as I did for number 3, right here. Okay, please pause the video and do number 4. Okay, so I got the first factor is 4, the second one is x plus 5i, and the second one is x minus 5i. Okay, so I hope you got the same thing. If not, I hope you learn from your mistakes, okay, and you can do better next time. Okay, let's do the next one, which is number 5. So number 5 you have here is 25x squared plus 36. Okay, so let me model it for you for number 5. Again, you're going to use the sum of 2 squared. But do you see a common factor repeated in 25x squared and 36? Yes, you got it right. There's no common factor. Okay, am I going to factor out 25? No. Why? 36 cannot be divided by 25 evenly. So you leave everything alone. So now I have to ask myself, since I need to write each term as a square, exponent of 2, okay, what number do I square and I get 25x squared? Can it be just, can I write 5x squared? Okay, so if you write 5x squared, remember that x squared raised to the second power is going to be 2 times 4. I meant to say 2 times 2 is 4. So you end up with actually 25 times x to the 4th power. Because 5 squared means 5 times 5, which is 25. Are they the same? Nope. So since the square is already factored out, you don't need a square when you write it inside the parentheses. So make sure you don't write again the same number. You have to be 5x squared. Why? 5x squared multiply to what? Multiply to 5x to 5x times 5x. Okay, so you have to take the base. Okay, it's a product, so you take the base And the exponent tell you how many times the base need to be multiplied. So and it'll be 5 times 5 is 25, and x times x is x squared. So and then here it's going to be just 6 because 6 squared is 36. Then the factor is going to be 25x squared plus 36 equal to 5x plus 6i times 5x minus 6i. And that's the final factor form. So let me move on to number 6. So for number 6, what I have here is you have 4x squared plus 169. Okay, this is 4 x squared plus 169. And again, I need you to use the formula for factoring the sum of 2 squared, which is a plus bi times a minus bi. Please pause the video and factor number 6. So here's your final factor form. And you can see here that the a here is 2x, and the b here is 13. Okay, and then that's what you want to write inside the factor. And when you write inside the factor, always include the term with the I. Why? Because you have, it's a sum of 2 squared. It's a sum, it's not a difference. Okay, so let's do last one, number 7. Okay, please, I need you to pause the video and factor 9x squared plus 4. And voila, I hope you got the same answer. If not, okay, were you able to write each term as a square? Okay, so now whatever is below, like the base, we present the number to use as to write the complex conjugate. Okay, and make sure you use I next to it. Okay, so thank you for watching my video. Have a wonderful day and see you to the next one. Bye bye.